Hello, my name is Jordan Thomas. I'm an assistant professor in the Division of Animal Sciences in the College of Agriculture, Food, and Natural Resources, and I'm also a state cow-calf specialist with MU Extension. And my topic today is sex semen and the costs, the benefits, and the systems that we have for successful application of that technology in the beef industry. So first of all, it's a pretty rapidly evolving area. And so there are two different processes that are used in commercial production of sex semen. And we should talk about both of them. The one that has the longest history is the flow cytometry based method of actually sorting sperm cells. And that's why we often talk about sex sorted semen. Uh, and that is a technology that was developed in the late 80s and early 90s to actually sort cells based on whether they contain an X or a Y chromosome. Most of the product that is on the market today in terms of sex semen is produced using this technology, either by Sexing Technologies or via that company's technology licensed out to other companies. And that's what you will, for the most part, see. But there is also a newer product that is now marketed, also a sex product, but not technically sorted, but rather the sperm cells have been ablated or destroyed if they're not of the desired chromosome content. And that is the Sex-L product that is now available in the marketplace. So we should briefly compare those. There are a couple things to know. One is that the Sex Ultra 4M product, that's marketed as either an X bearing, so that'd be used for production of heifer calves, or Y bearing, used to produce bull calves or ultimately steer calves. It is not marketed for every bull. We'll talk about why in a moment. The sex ablated semen product is currently only marketed as an X bearing product. Certainly possible to use that technology to make Y-bearing units, but just not a Y-bearing product on the marketplace yet. The Sex Ultra 4M product is marketed as being over 90% accurate. In other words, producing calves that are of the desired sex 90% of the time or higher. We've always found it to be a little bit higher than that in our research trials, but technically you could set that accuracy with this technology to be just about anywhere you wanted it to be. It would just affect how many units of sperm cells you can actually produce. So they feel like 90% is about the range to operate in most of the time, and that's what most of those products are sold and produced at. The Sex-L product is marketed as being similar to the other sex semen products on the marketplace, which is this one. And so if you look at the published literature, they're right up there. There haven't been these head-to-head comparisons with Sex Ultra, and that's, different companies with different technologies. And so we may never have one of those, but certainly in that range for that product as well. In terms of the challenges with sex semen, whether it's sexed sorted or sexed ablated, what we're talking about is a quantity and a quality issue. So from a quantity standpoint, we have a lower sperm cell number per dose in a unit of sex semen compared to conventional. Usually conventional semen is about 20 million cells per unit, somewhere in that range. It's a little bit bull dependent whether that really matters if it's a little bit lower than that. We know some bulls retain their fertility at very low sperm cell numbers. Some need those sperm cell numbers to be slightly higher, but most conventional semen is marketed somewhere between 10 and 30 million cells per unit, around 20 million fairly commonly. Sex semen, though, the old generation of sex sorted semen, prior to some of these Sex Ultra updates that have happened in recent years, they were produced at 2 million cells per unit. The old literature suggested that we didn't really see improved fertility with higher sperm cell numbers per dose of sex sorted semen, interestingly. With the Sex Ultra product, there has actually been a paper that suggested a meaningful improvement going from 2 to 4 million cells per unit. And so that's why you see that 4M on the end of that name. That's to indicate that they're now 4 million cells per unit. The sex ablated semen product is marketed a little bit differently. Remember, there's some of those cells in there have been destroyed intentionally. And so they market it as having 1.5 million live cells
after thaw, and that's an important distinction. The other ones are being referred to as the number of cells before thaw, and we know that often we have a reduction in about half the number of sperm cells just from the freeze thaw process. So just keep that in mind. Is there a meaningful difference in the number of cells necessarily? The jury's still out on that. Is there a dose response potentially with that sex ablated semen product? Jury's still out on that as well. We really don't know that from the literature, and it could be a promising area of future research or could not be. The bigger thing I want to focus on, though, is this quality issue with sex sperm cells. And the first thing to realize is most of this research is done with sorted sperm as opposed to the ablated sperm, the ablated product. But presumably this is happening in both cases. We just don't really have a strong understanding of that yet. But at least with the sex sorted sperm, it's fairly clear that the sperm cell membrane is being damaged, or maybe it's more appropriate to say it's being altered as a result of the sorting process. Now, if that damage sounds scary, right, but altered doesn't necessarily need to sound scary, because the first thing to remember is that sperm cells undergo an alteration process in the female reproductive tract anyway. They undergo this process that we call capacitation, just to gain the capacity to fertilize an oocyte. And there's a lot of good research being done on how that process works and how we can identify sperm cells at varying stages in that process. Being done here at the University of Missouri, for example, Dr. Carl Kearns, who was a postdoctoral fellow at Mizzou and has now moved on to Iowa State, has a series of nice publications, very high-profile publications out of our Division of Animal Sciences and Peter Satowski's lab. And there's a lot of emerging literature that is shedding a lot of light on how exactly this process works and how we can think about it. But what we're beginning to think of, or what we're beginning to conceptualize this process as, is with this idea of waves. And that's why I have that picture on the right-hand side of the screen. If you think about waves of sperm cells, it leads us to think about fertility in a different way. So we always think about fertility as high and low, right? Percentages. And really, the actual science would suggest we ought to think about it more two-dimensionally. In other words, fertility over time. So if you think about a wave of sperm cells gaining this capacity to fertilize, those sperm cells are very fertile in that period of time in which they are capacitated, but that's also the beginning of the end for those sperm cells. And so if we really want to have fertility over time, we need to have different waves of sperm cells undergoing this capacitation process at different time points. And that's how you would cover a fairly substantial period of time. If you had all of the sperm cells capacitated, is that a subfertile unit of semen? Not necessarily, but it would need to be placed in the reproductive tract very close to ovulation in order to achieve optimal fertility. If it was placed too early relative to ovulation, we could have just this mismatch in terms of these fertile windows of time. So that's often how we think about sex semen. Are there some underlying fertility challenges with sex sorted semen? I'm going to leave that question alone a little bit today, but the literature is very mixed on that, and whether there are meaningful fertilization failure rates that we are observing even in vitro fertilization contexts and things like that. The data is a little bit mixed on embryonic effects, specifically of sex sorted semen. And so we'll forgo an extensive discussion of that today. We'll also forgo an extensive discussion of this interaction of the freezing process. It looks like a little bit fresh sorted semen may actually offer a better opportunity than frozen sex sorted semen. But as you think about the logistics of trying to use frozen semen, particularly in the beef business, where a lot of what we do is seasonal, it's just a logistic nightmare, quite frankly. So the other question that's going to be hard to tackle today, but I do think it's important to note, is that there are multiple differences in fertility. We know that with conventional semen. Same is true with sex semen. But the wrench that gets thrown in all of this is just because a bull has high fertility with conventional semen
that's no guarantee that bull is going to be high fertility with sex sorted semen. And we don't have the best ways of really understanding which bulls are going to be highly fertile after their sperm cells have been sexed. So keep that in mind. And if you do try to use some sex sorted semen, it's worth asking the AI technician or the semen company that you're getting that semen from whether or not they have any indication of success rates with that particular sire. That's about all we have right now is those kinds of word of mouth, anecdotal accounts of fertility. Some bulls simply will not tolerate, or some sperm cells from some bulls simply will not tolerate the sorting and then freeze thaw process, and they're just not fertile, not viable cells after freezing and thawing if those cells have been sorted. So not every bull will even successfully sort and produce sex sorted semen. There's also some question as to whether we see some of these differences more in time to eye than we do in heat detection. But in terms of trying to apply use of sex sorted semen in the real world, a couple things really matter, and these are the real key points that I want to emphasize today. The first one is when estrus expression occurred matters. And the other is whether estrus expression occurred really matters. So in terms of the when piece, cattle are in standing heat for variable lengths of time. And that depends on the individual female. It's affected by all sorts of things. But one thing that is fairly consistent is that the LH surge, which is the actual really critical hormone for the initiation of the ovulatory process, that happens essentially at the onset of estrus, at the onset of standing heat behavior. And the interval or the length of time from that surge until ovulation is fairly consistent. It's about 30 hours with a range around it. So if you, getting back to this idea of timing, it looks like based on the literature, we really want to be closer to ovulation with sex sorted semen than we would typically have to be if using conventional semen. And here's a little bit of that data. I just want to pick the highlights out of this. If you look on the left side of the screen, don't worry so much about those two different lines, but just look at that relationship in terms of the probability of pregnancy occurring on the vertical axis and the time at which insemination was performed. And in this case, they monitored estrus activity as a function of how active the animals are. That's a fairly common approach in the dairy world. But if you look, if AI was performed essentially at the onset of estrus activity, very low fertility. If AI was performed substantially later after the onset of activity, much higher fertility. The same thing just looked at in about the opposite way, thinking about relative to ovulation, is expressed on the right-hand side of the screen. And if you just look at, for example, the row across there at the top, in which cows were inseminated greater than 24 hours in advance of ovulation, they had terrible pregnancy rates in this paper, 5.8% to AI if insemination was performed that early relative to ovulation. But if you look, if insemination was performed much closer to ovulation, a significant increase in the pregnancy rate of those cows. So when estrus expression occurred matters, and also whether estrus expression occurred matters. And we think about that more in time to eye applications. So if you're using sex sorted semen in time to eye, this is money well spent. Use an estrus detection aid of some form. I've used Estrotech patches a lot in our research trials. That's a very inexpensive, very effective tool. But this can really increase the accuracy of your heat detection program if you're already in heat detection, and also really open you up to making some good decisions in terms of time to eye as well. So here's one opportunity from a time to eye standpoint. This is some work done at South Dakota State University, and I show this because this is some of the only data I'll show today with the sex ablated technology. For those of you that might be interested in that. If you look on the left-hand side, pregnancy rates are reduced. If you're using that compared to conventional semen, that's fairly common, whether we're talking about sex sorted or sex ablated semen. There's some level of reduction. But if you look there on the right, if the dark gray bars being the sex sorted units, or the in this case they're calling it gender sorted, but the sex ablated units. and the lighter gray bars being conventional semen, those animals that had an activated patch, still a reduction using that sex product, but at much more comparable to conventional than if, for example, on the far right-hand side, those animals that did not have an activated patch, if they receive sex semen, that reduction is much larger. Now, we see the same thing in our research as well, and I'll show you that in a minute. But if you are using this in heat detection, check animals a minimum of 3 times daily, and then also err towards performing AI later after onset of standing heat than you would with a traditional AM/PM rule. But in a timed AI application, identify animals that have expressed standing estrus and try to restrict sex-sorted semen, probably in most cases to only those animals that have an activated estrus detection aid. You can still use it theoretically in those that don't, but you would just need to expect much lower pregnancy rates as you would with conventional semen, but it appears that you're going to get an even larger reduction with sex semen, and that's fairly consistent in some of our work as well as some work done at other institutions. That cost benefit, right, is really what we're thinking about. Does the increased cost of the sex-sorted semen really justify, or can that be justified by the results that you're obtaining, the number of pregnancies resulting from sex semen? I would also suggest that you think about using a timed AI approach that results in a very high total heat response before the time of AI, because that allows you to service as many females as possible with sex-sorted semen. A lot of producers are inclined to think, because of this relationship of timing and having heard something about that, that maybe that means they ought to perform timed AI slightly later. That's not the case. At least that's not the case yet in any of the research that is published and really solid. In fact, all of the research that's currently out that has looked at later timing of timed AI with the standard protocols would suggest that results are either the same or slightly worse using later times of timed AI. Why? It's probably because timed AI is already a compromise. And so if we are scooting that time of timed AI even later, we're actually giving up just about as much on the early end. So of those females that came in heat earliest, as we potentially pick up on those that are being inseminated at a more optimal time. A better solution would be to do something a little bit different rather than just a truly fixed time AI. Split time AI is a great opportunity if you're interested in trying to use sex-sorted semen, or if you just want a little bit of a boost with conventional semen. And that would involve applying one of those estrus detection aids and then only inseminating the females that have expressed estrus, that have come in heat by the standard time of fixed time AI at that time, and delaying insemination for those that have not until the next day. Fairly straightforward approach, but essentially it works out to something like this. If you're using split time AI, you get that proportion that you would expect, and this is based on a fair bit of published data for this particular protocol, the 14-day CEDAR protocol. Very strong heat response before the time of fixed time AI, typically with that protocol. But by delaying insemination for that remainder of the females that have not come in heat by that time, you pick up some additional estrus expression. You pick up an additional group of females that you can use sex-sorted semen on very effectively. And it minimizes the number that you're forced to use conventional semen on, and also the number that, achieve a fairly low pregnancy rate. Here's what that looks like if you're curious about some of those results. Again, this is some work that we did several years ago, but those females that express estrus before the standard fixed time AI time or during that delay period, exceptional fertility with conventional semen, very, very, very acceptable fertility with sex-sorted semen. In fact, very good, really, if you think about what that actually translates to. And still poor fertility if they have not expressed estrus, but remember that proportion of the females has been minimized if you do this approach. Here's a common question. If I use sex semen for timed AI, am I just going to really get abysmal pregnancy rates in total by the end of the breeding season? It doesn't really look like that in our data. You just got to bear in mind that you're going to have fewer pregnant early, as early as possible in the breeding season, just by definition, because you sacrifice some pregnancy rate to AI in order to get the desired sex of calf. So that's just part of what you need to factor in as you think about the costs and the benefits of using this technology. If you're interested more in the split time AI concept, we do have an extension publication available on that, and there's a link to that there. And you can sure email me if you can't find that as well. I did want to mention, though, looking forward, what are some of the emerging opportunities for use of sex-sorted semen? And you know, I think it's an exciting time. Number one, what would this actually allow us to do? Not only in the seed stock world, where I think it's very easy to wrap our head around, you know, use of this technology to make elite bulls or elite females, but even on the commercial side, I think there's a lot of applications. And one would be to do something very similar to what the dairy industry is already doing, identifying the top end of the cow herd, the elite females that really ought to serve as our seed stock, you know, our internal elite nucleus of cows that can produce high quality replacement females. The dairy industry is doing this very aggressively. It's opened them up to use a lot of beef semen actually on the lower end of their dairy herd to produce crossbred calves. And you know, we can think very similarly in the beef industry and be very aggressive about making genetic progress as well. Also, you know, replacement heifers could always produce heifer calves. You get that faster generation interval. You get some advantages there with minimized dystocia. It could also lead to more specialization, right? So you may be a producer that really excels in producing high quality replacement females and replacement quality females, and maybe you market them and show me select or something like that. You know, that's a program we're very proud of at the university, but there's all sorts of ways to go about doing that. Maybe you're a producer that has a really strong opportunity to market terminal calves, and you could use a male sex sorted semen to increase the quantity of, you know, half sibling bull calves that you have. And gosh, that's a tremendous opportunity depending on what scale you're at, and may push you into more of a, you know, opportunity to market pot loads of cattle, you know, semi loads of cattle, as opposed to smaller lots. Also think about this. You know, I'm a big proponent of crossbreeding personally, and I realize that many of you like your straight bred cattle and you want to use, you know, the straight Angus cow, and so be it. You know, if that's what you want to do. Crossbred cattle do, based on the literature, outperform straight bred cattle in terms of their longevity in the herd, their reproductive performance, et cetera, et cetera. But if you do want to do a straight breeding program, you know, can you use more of a crossbreeding like mentality and identify sires that maybe are more terminally focused within that breed or more maternally focused within that breed? And can you plan matings in such a way that maybe you introduce a little bit of that crossbreeding mentality into your program? So I think those are some of the opportunities. I would encourage you, whatever you do, run the numbers. And I wish I could do all of that for you, because it would sure make things easier in extension. But unfortunately, there's a lot of little details that are going to be specific to your operation that affect whether this makes sense. And there's a lot of moving parts. There's a good decision-making tool that's, unfortunately, it's pretty complicated, but Texas A&M AgriLife Extension has a very complete decision-making tool about use of sex-sorted semen. I'd refer you to that. If you're a numbers person. If you're not a numbers person, I think you can do some reasonable, you know, back of the envelope calculations as well, and just assume, you know, a modest reduction in pregnancy rates with sex semen compared to conventional, and try to figure out what the actual advantages are specific to your specific context. Also use estrus detection aids. If you're going to do a heat detection program, or if you're going to do a timed AI program, add that into your program if you're interested in using sex sorted semen, and think also about, you know, how you carry out the AI program, and try to do something that makes some sense. If you're going to be using, say, the 14-day seeder in heifers, I would look very hard at the split time AI publication that we have out. That's a very strong platform to use sex sorted semen in heifers. I'll give you a little spoiler on another field day talk. We do have a new protocol that we've worked on a lot in our program called 7 and 7 Sync. It's a great opportunity for postpartum cows. We have very strong results with that using either conventional or sex sorted semen. And so see Carson Anderson's talk in this virtual field day series about that. very good opportunity to use sex-sorted semen effectively in postpartum beef cows as well. I do hope you'll keep in touch with us. We're on social media in a few different places and have a YouTube channel and things like that. You can find us on Facebook or just about anywhere if you just search for Mizzou Repro. I wish I could take questions. I wish we weren't virtual. I know it's a different way to do it, Ag Experimentation Field Days, but you're certainly welcome to send me an email if you have any questions on this content, or give me a call. That's my office number there. And you can reach out to me again at Mizzou Repro just about anywhere as well. So thank you for listening.